Welcome to The Explainer. I'm absolutely thrilled you're here today because, well, we are unpacking a massive, fundamental shift happening right now in AI. We're talking about the transition from standard language models to deliberative AI architectures. And look, this isn't just some minor update under the hood. It's a total structural and, frankly, financial reinvention of exactly how we build enterprise software with AI. Let's dive right in. Here's our roadmap for this explainer. We'll start with the deliberative paradigm shift, then look at latency and performance baselines. After that, we're navigating API state management, diving into fiscal engineering and cost, and we'll wrap it all up with a strategic deployment framework.
All right, Section 1, the deliberative paradigm shift. We are moving from immediate prediction to internal planning.
So you've probably heard the term serial test time compute. This is the absolute engine behind modern reasoning models. Instead of just immediately guessing the next word, these models allocate extra compute internally. They systematically evaluate alternatives, actually fix their own mistakes, and plan out complex, multi-step tasks before you ever see a single word pop up on your screen. And this is exactly why these newer models are just crushing it, achieving vastly superior capabilities in logic, dense document analysis, and coding. Think of our legacy, immediate, autoregressive models like an improviser on stage. They just get up there and start talking, predicting the next word linearly. Deliberative models, on the other hand, they act way more like a strategic planner. They think silently, they use invisible tokens to map out an entire solution before they ever open their mouths. It's a literal complete architectural shift from simply talking to actually thinking. Okay, moving to Section 2, latency and performance baselines. Let's look at the real-world impact on speed. If you're building enterprise apps, you're pretty used to a time-to-first token, or TTFT, of under a second, right? You can see that right here with the standard Claude Haiku 4.5 clocking in at 0.96 seconds. But look at a deliberative model like Mimo v2.5. The total execution time for a coding task stretches to a massive 35 seconds. No way around it, because these models generate invisible tokens internally before answering. Our traditional low-latency performance metrics are suddenly completely obsolete. Which brings us to this frankly shocking metric, 46 seconds. That right there is the 90th percentile tail latency for the Hunyuan 3 preview on a coding task. Think about that for a second. Because the length of the model's internal planning sequence dynamically changes based on how hard the prompt is, your latency becomes incredibly volatile. If your enterprise SLAs guarantee a response in 2 seconds, yeah, dropping a deliberative model into that pipeline is going to break your app instantly. So how do we handle this? Section 3, navigating API state management. We're engineering the new API designs. Let's break down OpenAI's new Responses API. The game has changed here. You're no longer just sending a prompt. You're actually controlling how hard the model thinks. You use the reasoning effort parameter, which ranges from none up to X high, to control the depth of deliberation. They've also introduced a pro mode, and that aggregates extra work for difficult logic. But crucially, and you'll want to pay attention to this, if you're maintaining a conversation history, you have to use the reasoning context parameter. This decides if you want to pull in the invisible planning steps from previous turns or restrict it just to the current turn to save on your context window limits. Now, Google Gemini does things a bit differently. They treat these internal thoughts as cryptographic signatures, and man, they have strict rules. Rule number 1 is the first call rule. If the model pauses its thinking to call an external tool, you absolutely must include its cryptographic thought signature on the very first function call of that turn. If you don't, the API instantly throws a 400 validation error. And their parallel response order rule is just as strict. If you trigger multiple tool calls at once, you have to send all the calls back first, strictly followed by all the responses. Absolutely no interleaving allowed. Moving over to DeepSeek R1, they give us yet another unique structural payload design. They output their internal trace in a specific reasoning content parameter. Now, if the model just answers your question with plain text and no tools are used, you can safely drop that massive think block from your conversation history to save tokens. Sounds great, right? But, and this is a massive but, if the model calls an external tool, that reasoning content block acts as the explicit justification for exactly why it called the tool. Omit it from the payload in your next turn, and DeepSeek's API gateway will flat out reject your request. Let's look at Anthropic's Claude 3.7 Sonnet to see how this builds even further. Claude uses a hybrid setup.
They're actually moving away from manual token budgeting and heavily pushing what they call adaptive thinking, where the model itself decides its token budget on the fly. When it comes to tools, they lock it down tight. You can only set tool choice to auto or none. You just cannot force a specific tool anymore. Oh, and take note of this one. Changing your thinking parameters midstream will instantly invalidate your prompt cache. Yep, meaning you start paying full price for your input tokens all over again. Which perfectly segues into Section 4, Fiscal Engineering and Cost. Let's talk about the real financial implications of those invisible tokens. The financial shockwaves of these deliberative models basically boil down to one simple equation. You pay for input tokens, you pay for the visible output tokens, but you also pay for the invisible thinking tokens. And here's the kicker. Across all the major providers, those thinking tokens are billed at the most expensive output token rate. Even if you tell the API to hide the raw planning text just to save on network latency, you are still getting billed for every single token the model generated internally. To put that into perspective, look at this crucial point right here, 7x. This is a staggering real-world cost multiplier. For example, a standard 500-token visible response from Claude 3.7 Sonnet might cost less than a penny. But if that same model decides to generate, say, 3,000 internal thinking tokens before it gives you those exact same 500 visible tokens, the cost of that transaction just jumped to over 5 cents. I mean, your API bills can literally balloon sevenfold overnight if you aren't careful. Because of this, engineering teams have to implement some really strict fiscal mitigation strategies. First up, enforce hard caps. Use parameters like max output tokens as a hard limit to physically prevent the model from entering some runaway, super expensive internal planning loop. Second, you've got to implement dynamic routing. Build an orchestration layer, and whatever you do, do not send every single query to a deliberative model. And third, aggressively optimize your context windows. Use settings like current turn to make sure you aren't constantly paying to reprocess thousands of old thinking tokens in a long multi-turn conversation. All right, moving to our final section, Section 5, Strategic Deployment Framework, or when to actually use these models. To really navigate this space successfully, you've got to pair the workload to the architecture. Got something with high logical complexity, like complex debugging across multiple code files? Route that to a deliberative model like Claude 3.7 and just accept the 30-second wait. What about high document density, like synthesizing restrictive clauses across 50 financial contracts? That is an absolutely perfect use case for an OpenAI O1 or O3 model. But interactive conversation or creative drafting? No. That belongs exclusively to standard models like GPT 4.5, where you get that snappy, sub-second latency the user expects. Let's be real. Throwing a deliberative model at a basic customer service chatbot or some simple text extraction pipeline is, quite simply, an expensive mistake. Standard models are already incredibly optimized for that kind of linguistic pattern matching. Adding a 15-second silent planning delay to a transactional chatbot, that completely degrades the user experience without giving you any proportional increase in quality. You really want to reserve these engines for high-value targets. Things like algorithmic debugging, resolving pre- and post-money valuations in finance, and evaluating heavily ambiguous prompts. So, I'll leave you with this final thought. Are you currently routing cheap, standard tasks to highly expensive deliberative models in your enterprise? Look, the architectural paradigm has shifted, and if you aren't actively managing the state, the latency, and the downright shocking cost of these invisible tokens, you're just burning resources. It is definitely time to audit your API routing strategy. Thanks so much for joining me on this explainer, and I'll catch you next time.